To all of you joining me for this video, thank you for joining me and welcome. Let's look here at this single compound and we will name it. It's a Fisher projection. This Fisher projection must be named and we will do it appropriately. When I'm looking at, I have an alcohol, I have a hydrogen, a hydroxyl hydrogen, and an aldehyde. And these intersection points represent carbons. If I were to expand it out, I'm really looking here at an aldehyde over here. Then I have a carbon and a hydroxyl, then a hydrogen. Then I have a carbon, a hydroxyl, and a hydrogen. And here I have a CH2OH. I'm looking here at a 1, 2, 3, 4 carbon compound. But I have stereocenters over here. These are chiral carbons because these carbons here are attached to 4 different items. Therefore, I must come up with an R or S designation, and same over here. Is it R or is it S? We must determine that so we can name this compound. When I'm looking over here, and this is where I'm starting, I bring it out. The Fisher projection looks something like this. I have an aldehyde, I have a hydrogen, and here I have a rest of the molecule. Everything below it's rest of molecule, capital R, then I have a OH. It's easy when you're doing it. You can either do the number system 1, 2, 3, 4, where 1 is the highest priority, 4 is the lowest priority, or you can do A, B, C, D, where A is the highest priority, D is the lowest priority, everything based on atomic numbers, and I'm going in the A, B, C, D system. When I'm looking at this, I clearly know I have a hydrogen, which is the D, lowest priority, and hydroxyl, which is A, highest priority. Why? Because the atom directly attached to your chiral carbon, the highest atomic number is a O over here. Here I have a carbon attached. Here I'll also have a carbon attached. As you can see, a carbon. This is the highest priority. Now I need to determine which one is higher priority. If you look at the aldehyde, it's a C double bond OH. If you open it up, it really is represented as a C with an oxygen, and a hydrogen. If you look over at this R group, what does this R group represent? It represents this carbon right here, but this carbon is attached to a hydrogen and it's attached to a hydroxyl, but I'm only putting the immediate oxygen atom. Then it's attached to an alcohol, CH2OH, but I'm looking at a C. If you compare this with this, which one looks higher priority? Here I have a carbon with 2 oxygens, here I have a carbon with 1 carbon and 1 oxygen. This is the higher priority, meaning the aldehyde is the higher priority and the rest of the molecule is lower priority in comparison to that. So this becomes B, and then the rest of the molecule becomes C, and let's erase this clutter so you can see what we have. This is what I have. When I'm doing Fisher projections and I want to determine is it R or is it S, my lowest priority must come on the top. That means my end result must have a D here on the top, and I can do so by means of double exchanges. I'm going to do a double exchange. My double exchange will be, I'll exchange B with D and I will exchange A with C. This right here is a single exchange, this here is a single exchange, but in its totality it represents a single double exchange. You should always at least do one double exchange if your lowest priority is not already on the top. It isn't, so do a double exchange. This alone does not count. You must do 2 single exchanges, which constitutes a single double exchange. When I do it, my D comes here on the top, my B comes here on the side, my A comes here on the bottom because I'm trading A and a C, and I'm trading D and a B, and my C comes over here. Now I'm looking in the direction from A to D. I'm looking in the direction of A to D, and you can always skip D and you can do A, B, C. I'm doing A, B, C in this direction. It's counterclockwise, so I know it's an S. When you go counterclockwise in terms of your rotation of that arrow, or the curve is in a counterclockwise, it's an S. You're doing A, B, C, you can skip D. And it's an S and it's done. Now we must evaluate this stereocenter. When I evaluate this stereocenter, what do I have? I have a hydrogen here, I have a hydroxyl here, I have a CH2OH, and then I have a rest of the molecule, because from above here everything is the rest. I know automatically this right here is A. So when I'm looking at it, I know this here is A, this right here is my lowest priority D. Which one of these is B, which one of these is C? Look at it. Look at this CH2OH. You are looking here at a carbon with a hydrogen because you're evaluating with regards to this. This carbon is attached. This is my chiral carbon, is attached to a carbon, but it's also attached to a hydrogen, and it's also attached to oxygen, and we'll stop right there. When I'm looking at this, which is the rest of the molecule, what do I have over there? I'll put it for you right here. Here's my chiral carbon, and I'm looking at it, and I have an immediate carbon. But to that I have a hydrogen, to that I have an oxygen, to that I have a aldehyde group, which is a C with the O, with the O, with an H. When you start doing a comparison between this and between this, you know clearly this outweighs in terms of priority that. So the R group over here becomes your B, your CH2OH becomes here a C. Now you can do a double exchange, but before we do it, let's clean this out. Your double exchange must bring the D here to the top. So you must have a D on the top always. For a Fisher projection analysis, the D must come on the top. I will do a D and a B, and I'll do A and a C. This here is a single exchange, this here is a single exchange, but together they're a double exchange. When I do it, my B comes over here, my C comes over here, my A comes over here. So you're doing A, B, C. A to B to C, skipping D, and I'm going in a clockwise manner. So this here becomes R, and it will be right. The top stereocenter is S, the lower one is here in the R. This is in a counterclockwise, this here is a clockwise manner, A, B, C. Now let's name this. We have here 1, 2, 3, 4 carbons ending with an aldehyde. It will be here ending as a butanaldehyde or butanal. Al represents an aldehyde, and you can leave it to that. You don't have to write aldehyde, butanaldehyde. You can just say butanal, and it will be correct. We have here carbon 1, carbon 2, carbon 3, carbon 4. We have 1, 2, 3 hydroxyl groups. I have hydroxyl groups which are attached to carbons 2, 3 and 4. So how will I say it? I'm looking here at a 2, 3, 4 trihydroxy. We'll bring the name out properly at the end. I have a 2, 3, 4 trihydroxy butanal. But now I must bring in the stereocenters. And let's start bringing it all together in a clear manner for you. So this is how my name is 2, 3, 4. On carbons 2, 3 and 4 I have hydroxyl groups. I'll say here trihydroxy, and you can do all in one word, butanal. That represents your main essence of your nomenclature, your name and everything. 2, 3, 4 trihydroxy butanal, but we must account for this, and we can. On carbon 2 I have a stereocenter which is S. On carbon 3 I have a stereocenter which is an R. In parentheses with a dash. 2, 3, 4 trihydroxybutanal or trihydroxybutanaldehyde. Either way it's fine. But this right here is a correct name, and it will be good. And that right there is the end of this video.